Hello, today I will be talking about waves. Waves is a phenomenon that occurs in everyday life. Everything from the x-rays doctors use to the waves in the water or the waves at a football game. There are two main ways to classify waves. The first is to deal with the medium, so what it goes through. Mechanical waves need a medium to go through. Example is sound. Sound needs air or water or whatever to go through to travel. The other example, so it needs a medium. Electromagnetic waves does not need a medium, so it doesn't need air or water to travel through. A good example of that is light. And when the sun's light comes to Earth, there's no medium that it goes through, being that space is empty and has no air. The other way to classify, no medium. Another way to classify waves is by the how it moves. So the other two ways is transverse and longitudinal. I'll just put longe right there. So transverse waves propagate perpendicular to the disturbance. So that means the disturbance, and it goes up and down like this. Longitudinal waves, they move parallel with the disturbance, much like such as that, going this way. An example of a transverse wave is a ripple on a pond, or light. Longitudinal wave, a good example is that it's maybe an accordion, where you're pressing down an accordion, how it flexes and moves. But a more distinctive example is sound. Sound travels longitudinally while light travels transversely. Now there are different parts of the transverse wave that is the most used, that being light. So I'll put a bigger example here. So top point of a wave is called the crest. The bottom point is called a trough. These are the maximum points of a wave. The amplitude is measured as the height or the maximum point of a wave. A wavelength is measured by how long it takes for one cycle to go through. So for a wave to go from here to here, that is one wavelength. It doesn't really matter, it doesn't have to be crest or the trough, it can be here to over here, but that is still one wavelength. Now the period or the frequency is how often it occurs. So that is, how often it occurs in one cycle or within a period of time. And then the speed or velocity is pretty self-explanatory, is how fast the wave is moving. Some basic formulas for waves to find the frequency would be frequency equals 1 over the period. So this divided by 1, or 1 divided by that. Another example is the velocity. To find the velocity, you would just take the frequency, you would divide that by the wavelength, the velocity. Now, an important idea that is often not explained is something called redshift. And so redshift is the idea that when an object moves away from us, its wavelength becomes longer and shorter. Meaning that it becomes less prevalent, less not powerful, but and so we call it redshift because as it moves away, the light shifts more towards the red end of the spectrum. A blue shift is when an object comes towards you, and so the wavelength becomes more compressed, frequency becomes higher, and moves more towards the blue side of the spectrum. A good example of this is the Doppler effect. When an ambulance is coming towards you, you can hear it becomes louder and louder and louder, much like a frequency of an object coming towards you becomes higher and more prevalent. And once it's right next to you, is at its highest point, and as it goes away, it greatly and drastically reduces. And so blue shift and red shift has helped us understand that the Earth is expanding, or the universe is expanding and is continuing to accelerate away from us. Are there any questions?
Yeah, so if you were standing 200 meters away from a speaker in space and it was playing loud music, would it be louder or quieter than it would be on Earth?
That's a trick question because sound is a mechanical wave, so it needs a medium of transit. And since space has no air, there will be no sound.
Okay.
Drop the